Instead of starting with spectacle, this process begins. Papayas grow across large agricultural regions, shaped by climate, timing, and careful harvesting decisions. What happens after harvest is not just transportation, but the beginning of a tightly coordinated production system designed to preserve quality while operating at scale. This is not simply a story about fruit. It is a story about how modern food systems manage speed, hygiene, and consistency at industrial levels.
Bay 3 is clear. Copy that, moving in now.
Papayas are harvested at specific ripeness thresholds, chosen not for appearance, but for how the fruit behaves under processing conditions. Once collected, the fruit is quickly transferred into temperature-controlled logistics. At this stage, time matters more than distance. Delays can alter texture, sugar balance, and microbial risk before the fruit ever reaches the factory. The goal is not speed alone, but predictability. Upon arrival, papayas enter a closed handling system. Human contact is deliberately minimized, not for efficiency alone, but for hygiene and repeatability. Water-based flume systems and controlled washing stages remove surface contaminants while protecting the fruit structure. Every parameter, flow rate, temperature, exposure time, is engineered to balance cleanliness and product control. Automation here replaces variability in control. At industrial scale, inspection cannot rely on human judgment alone. Optical systems analyze each papaya for size, surface condition, and internal defects. Decisions happen in milliseconds. Fruit that does not meet processing criteria is removed automatically, preventing downstream disruption. This is not about perfection. It is about maintaining stable input conditions for the rest of the system. Once accepted, papayas move through peeling, deceiving, and cutting stages designed for uniformity. Machines do not adapt intuitively, so engineers design the fruit flow to behave predictably. Blade angles, cutting speeds, and positioning systems are optimized to reduce waste and maintain consistent output. What looks mechanical is actually the result of biological data translated into engineering skills. For canned products, precision becomes critical. Filling volumes, syrup ratios, and sealing pressure are continuously monitored. Sealed containers are then sterilized under carefully controlled temperature and pressure conditions, ensuring safety without compromising texture. This balance between preservation and quality is one of the most difficult problems in food engineering. For smoothie and puree production, the system shifts again. Papaya flesh is converted into pulp, blended and homogenized to ensure stability over time. Sensors track viscosity, temperature and composition to maintain uniformity across thousands of bottles per annum. Here, automation replaces not labor, but inconsistency. Packaging is not the final step. It is the transition point between production and distribution. Robotic systems handle case packing and palletizing to protect products while maintaining cleanliness. Storage systems organize output not by appearance, but by logistics. Every movement is calculated to reduce handling, delays, and damage. Modern papaya processing is not about removing people from the system. It is about repositioning. As automation increases, human roles shift toward oversight, maintenance, and system design. The factory becomes less about manual effort and more about managing complexity. Behind every finished product is not just machinery, but a series of decisions about how food should be handled, preserved, and delivered at scale. Understanding this process means understanding how modern production systems quietly shape what we consume.